What's going on, guys? It's your boy Sam. Hope you all are doing great. And in this video right here, I'm going to give you an introduction to algorithmic trading. And this will be the beginning of a series where we'll actually start studying different trading strategies. So, yeah, if you're new to the channel, subscribe so you won't miss the other series. What we're going to do today is we're going to extract historical price data for a specific stock symbol from Yahoo Finance. And after that, we'll examine a simple strategy to see whether it can be profitable or not. But before we get started, I want us to go through some concepts, some terms, so we really understand what we're doing here. The first one is the simple moving average, SMA. What this is basically is it's a trend follower indicator which can be calculated by calculating the algorithmic mean of a given set of values. In other words, a set of numbers or prices in the case of financial instruments are added together and then divided by the number of prices in the set. Now let me give you an example, guys. If we wanted to calculate the SMA 20 value in the current point, we would add up all the last 20 days closing price and then divide them by 20. The moving average strategy suggests that buying a stock when it has a shorter SMA crossing over a longer SMA and also selling it when the shorter SMA crosses down the longer one. And in the picture that we're seeing right now, we can see that it shows us the buy signal for SMA 20. The red line crosses over the blue line, SMA 50, and the exit point as vice versa. And you can see here that the SMA 20, which is the red line, crosses over the blue line, which is SMA 50. Okay, now that we understand the simple moving average, what we need to do next is we can actually start writing some code. The first step is data extraction and preparation. Now, what I want you guys to know is that historical data can be found from various sources, but we're simply going to use Yahoo Finance. And to do this, we'll need to import the Y Finance library and other related libraries which can be used on data manipulation using pandas. So now you can see that we've installed, and down in the description below, you will see a link to all these libraries right here. It'll take you to a web page. All you do is you just copy the command and you paste the command in your terminal right here, and it will install the library for you. So that's all you need to do. Okay, guys, the next step is that we need to define the time range that we'll examine the strategy for. So to use Y Finance library, the date should be in the format of year, month, and day. What you need to do is you need to define the start date as your own favorite time, and you can do the same for the end date. But I prefer the end date to be as of today, so it can be current, and we can define it below like this. You say start is equal to 2018, and this has to be in quotes 2018. After that, we say 01-01, and then we say end is equal to dt dot datetime dot now. So this is the format we're using today and also 2018-01-01. In the next step, we need to store your favorite stock symbol ticker string in a stock variable. And we're going to use the Yahoo Finance library to download it as a data frame. And in our case, I'm using Tesla, so I'll say stock is equal to TSLA. That's the symbol for Tesla. And after that, I'll create a variable called df. I'll set that equal to yf.download. And the arguments we're going to put there is our stock, and then we also put the start date and the end date, and also the interval. And the interval is basically how many times we want it to check, and it's going to be 1 day. The head. And all we need to do right now is we'll say print df. So right now you can see right here that we get the open, we get the dates, we get open, we get high, we get adjusted close, and also we have the volume as the last row. Here, guys, what I did is I selected a TSLA, which is for Tesla, and I stored the price data in a data frame using the download attribute of Y Finance. And there are several parameters that we should include, such as the stock, the start date, the end date, and also the interval. And what we did at the end is that we added the default sampling interval, which is 1 day, but you can easily choose a different or an other interval. What I'm going to do here is just put some comments so you really understand it. Here we define the time range, and after that we actually chose our favorite stock symbol. Now what we're going to do next is we're going to actually calculate the simple moving average, our SMA. And the way we do that is we say short underscore SMA, and we set that equal to 20. And after that we say long underscore SMA, and we set that equal to 50. What we do after that is create a list. We'll call it SMAs. And this list is going to have short SMA and also long SMA inside it. What we can do now is we can calculate the moving average one by one for each SMA using the rolling and the mean function. But to make it more flexible, we'll use a for loop for that. And let me show you how we do that. So we say for I in SMAs, that's the list. What we want to do is we say df, and then we'll say SMAs underscore. And what we do is we'll concatenate it with I right now, but to do that, we need to convert I into a string. That will set it equal to df dot iloc, and we want the fourth row, which is our adjusted close price, colon, and then a comma, and we put 4. After that, we say dot rolling window, and we set window to I. And finally, we say mean, call the main function. Now, if we run it, we shouldn't get an error. That's the most important thing. And you can see we didn't get an error. So that means everything is working out perfectly. But just so we can make this a little bit more versatile, we can also, in this case here, that we have it stock to Tesla, we can ask the user for input. So we could basically just put it right here. We'll say input, and then we'll say enter your favorite stock symbol. Put a colon after, and then we create a space just to make it more user friendly. Now let me show you how it looks like. The first thing it does is it's going to ask us for the stock symbol. In our case, we'll say TSLA, and then we get it working like this. So this is another way you could do it, just in case you want to try different stock symbols. Now let me just explain this line of code right here. What we did right here is that we said for each SMA, we want to calculate using the rolling function in the predefined time window for the adjusted close price, which is the 5th column of the data frame. Then each SMA will be added as a new column with the name of the SMA suffix with the time window we prepared. And to see the result, what we do is we say df.tail. And when we do df.tail3, what we need to do next is we just print. So we print this and we run it again. It says TSLA. You can see right here we have the SMA 20, we have the SMA 50. We have high, open, and the date. So this is the difference. This is the first one we printed right here. I could easily actually just comment it out so we only see the df.tail. Yeah, I'm gonna comment this out. And even this right here, I'm gonna comment it out and just do stock again. I'll set that equal to TSLA, so I don't have to always put that in the user input. Now we can see right here we have SMA 20 and SMA 50. Now guys, what we're going to do next is we're going to actually check the SMA's relative position recognition. And what this section is it's the backbone of the moving average strategy backtesting. The relationship position of these two SMAs should be defined to recognize the trend direction. And what this does is that it has simple basics. If the shorter SMA is higher than the longer SMA, That means that we're in the uptrend area and appropriate to have a position and sell it in the position condition. So you know what? Let's code to actually see this happen. What we do is we create a variable called position and we set that equal to 0. And what 0 means, if we made this to 1, this means we have already entered a position. But 0 means that we have not already entered a position. So that's why we set it as 0. And we also set a counter variable to 0. We'll set a percent change, set that to an empty list. Now we're going to say for I in df.index, SMA short is equal to df. And right here we say SMA underscore 20. Copy this and just change this from short to long and from SMA 20 to 50. Now we set close to df. And here we'll have adjusted close and then I after it. Now we need to set our condition which says if SMA short index I is greater than SMA long I, what we want to do is we want to print uptrend. So this is going to notify us that there's an uptrend. If our position is equal to 0, what we want to do is we want to say by P, by position, and then we set our position to 1. And we'll print a message that says buy at the price. We'll say plus, we'll convert it to a string by position, which is by P in our case. What we'll do next is we'll create an elif, and the elif condition is going to be less than instead of greater than. What I'll say is very similar to this, so I'm just going to copy this, paste it right here. Instead of uptrend, it's going to be downtrend. And if position is 1 in this case, we want to set our position to 0. And instead of our buy P, it's going to be sell position. Sell P is equal to close. Now what we'll print is we'll say sell at the price, sell P. We'll create a variable called pers, which is short for percent, and we set it equal to sell P divided by buy P minus 1, then we multiply it by 100. Now we say percentage change dot append this percent or this pers that we have right here. Now we've done that, we'll create a if condition and we'll say if counter is equal to df adjusted close dot count. We'll call our count function or count method minus 1, and position is equal to 1. What we want is our position to equal 0, our sell P to equal close, and we also want to print sell at the price plus str sell P. Now we say purse again is equal to sell P divided by buy P minus 1 multiplied by 100. Then we append it to our list again. All we need to do is update our counter. So say counter plus equals 1, and then we'll print percent change. This adjusted close right here should be capital close. And we run it. Now we can see right here that we get the downward trends, we get the upward trends, and we also get our buy at the certain price. So it's telling us when to buy, telling us buy at this price. Now I'm just going to change this a little bit because obviously I should create some spaces around here. Sell at this price, buy at this price. So it just looks better. I can put a colon right here, put another colon right here. Now let's run it again. You can see now there's a lot of data for each day it's showing us. So this is basically what it's showing us right here. It shows us there's an uptrend. It shows us the price we should buy it at. Shows us uptrend, downtrend. Then it shows us the price we should sell it at. Then it shows us, oh, downtrend, downtrend. Nothing is changing here. Oh, wow, there's an uptrend. Buy at this price now. And then you sell it. And then it shows us, oh, a downtrend, sell at this price. And it does this. And then whenever there's a no change, it keeps on becoming an uptrend. It doesn't say anything, doesn't tell us to buy or sell. When we get to a downtrend, then it tells us, oh, you can sell it at this price too. And it goes on like this. So you can see there's a lot of data because this is basically every day. This is a for loop block of code that will iterate over data set we previously read into the df variable. After defining the close price, the long and short SMAs from the data frame, it will go into two different branches using its statement based on short and long SMA values. And you can see that right there. If the short SMA is above the long SMA, it will print out the trend direction, which is upward. And if there is not existing position in the portfolio, it will buy a position. It will buy a position based on the close price of that day. And right here, if the short SMA reads a smaller value than the long SMA, it is in a downward trend. And if you don't already have a position, it will sell at the adjusted close price. Now look guys, using the append function, we'll store the result to a percentage change variable list as defined in the previous line. Now what happens in the last block of code is that to examine whether there's an open position, we'll be counting down to the end of the data frame. And that's what we did right here. And you can see right here that this list, we have the buy and the sell signals and all the trades stored in this list right here. So that's what makes this really cool. Yeah, and that's it for this part one, guys. The next part is we're going to deal with some of the statistics and then we'll finally start plotting and seeing some visualization of all this data that we have here. So watch out for the part two. That's it for this tutorial. Please leave a like if you enjoyed it, subscribe if you're new, and I'll catch you on the next one.